This video is going to talk about the organization of the periodic table, how it's organized. It's really, it's really organized in a unique fashion because the way it's organized, if you look at it from left to right, it makes sense. It all goes in order from based on the. Let me pull it up here. Based on the increasing atomic number. There you go. Hydrogen, helium. Again, here's the atomic number down here. Lithium, 3, 4, 5, 6, 7, 8, 9, 10. You can see each time that number is increasing. And so it makes sense going left to right, just like a book, each time it increases, but also makes sense it's classified going up and down. And so it's a two-dimensional classification system. And so we're gonna look at that. And one of the things we're gonna look at is periodic law. Basically what this means is that many of the chemical and physical properties of the element tend to recur in a systematic manner with increasing atomic number. And so elements are not only increasing from left to right based on their atomic number, but they're also grouped with their chemical and physical properties. So these elements are really organized in a way. It's not, it's got kind of a funky looking shape. It's organized in a way that actually makes a lot of sense, right? That they're grouped together with similar elements. We'll talk about it. Horizontal rows on the periodic table, I'm going to refer to those as periods. And then the vertical columns you can see down here are your groups. But the horizontal rows are from periods, so from left to right. And you can think of that just so you don't get confused with that. Like think of if I'm writing a sentence and I put a period at the end. How do I write my sentences? I write them across, I write them horizontally. I don't write vertical sentences. That'd be weird. So I write my sentences across. I put a period at the end. So my periods are my horizontal rows. I write sentences horizontally, and I put a period at the end. My horizontal rows are my periods. From left to right, the elements increase by 1 proton, and that's called the atomic number. That's something we've already talked about. The number of the period will also tell you how many electron shells an element has. All right, so how many energy levels there are in an electron. All right, so the periodic table will tell you, and I'm going to explain this in a minute. All right, so if you're like, what the heck's that mean? I'll explain that in a minute. All right, so it increases by 1 atomic number, and the period will tell you the electron levels. The vertical columns, vertical up and down, this is really going to be the key importance, right? Understanding how these are grouped. Elements in the same group usually share similar properties. All right, and I'll go through all this. And these are sometimes called, let me see if I can write this down. It's really hard to write on the smartboard. A lot of times people call these families. Because really what they do is they have common characteristics. Like it or not, ladies, you're probably going to turn into your mother one day. As much as you're like, oh, I can't stand my mom, she's so out of it. Well, you're probably going to be her because you share similar genetics. The only experience with having a woman in your life is having a mom, and so you're probably going to be like your mother when you grow up, as painful as that is to hear. Same thing with guys. You're probably going to end up being more like your dads, or you're going to be mimic some kind of male influence in your life. And so because once again in the families, you're either going to look like them or you're going to act like them or something, because they have common characteristics. We share similar DNA, and so elements are grouped in that same way. So groups are sometimes called families because they share really common characteristics, just like we do with our families. And they usually share similar properties. And this is going to be really important, having an understanding of this. Elements in the same group have the same number of electrons in their outer shell. Not the same number of electrons, but just their outer shell. And that's called a valence electron. Valence electrons are going to be so important for what we're going to be talking about with chemical bonding. The whole reason why atoms bond together is because of the number of electrons in the outer shell. So really understand that the group determines the valence electron, the valence shell. That's crucial for understanding this. All right, and I'll go through all this. It's really easy to figure this all out. So here's just some examples, like group 1. These are your alkali metals. Hydrogen a lot of times is in group 1. because of the electrons that it has in its outer shell, but they don't really fall into the alkali metal concept. So uh, every element in group one, they're the most reactive metals. All right, they're all very reactive. Like sodium, when it comes in contact with water, it explodes. All right, sodium is in group one. They're all very reactive. They're all very malleable. Right? Some can be even cut with a knife, right? Just like a piece of metal can be cut with a really dull knife. And they all have one valence electron, one electron in their outer shell. Actually, I'm going to explain that right now because I feel like that could get lost. So what I mean by valence electron, so you can see here's a shell model over here on the right hand side. If I click all the way down, and it's really easy. If I go all the way down group one, if I go lithium, sodium, potassium, rubidium, cesium, francesium, look at the electrons in their outer shell. One. Sodium's going to have one. Potassium's going to have, wait for it, one. Rubidium, that was a drum roll. Ah, stops making shell. Guess what? It would have one. See, here's the little electron structure. It tells you right there. One. All right, and then guess what group two is going to have? Two. Two. Calcium, two. All right, you get the idea. And then we skip over. Now, sometimes this is called 3A, like this periodic table calls it 3A. Some call it group 13. But basically, so we're going to skip. So we do one. These all have one. These all have two. We skip this dip. These all have 3, 4, 5. Once again, so you can see aluminum. 1, 2, 3. Just in that last shell. All right, that's all we're looking at. 1, 2, 3, 4. Just in that last shell. All right. These all have 4. All right. You get the idea. All right. Ah. I don't know what just happened there. There we go. All right, alkali earth metals. All right, and you're going to have to know this as well. All right, for some reason, our standard tells us that we have to know which one are the earth metals and which one are the alkali metals. So group one are the alkali metals. Group two are the alkali earth metals. I have no idea why we have to know that, but that's what we have to know. They're the second most reactive family of second most reactive metals, and they have 2 valence electrons because they're in group, you guessed it, 2. And then if you look at other things like group 11 has, I go to my periodic table, group 11, 3, 4, 5, 6, 7, 8, 9, 10, 11. Group 11 has, this is copper, whoops, my bad, has copper, silver, gold. All those are shiny metals. Let me find the shiny metals, good conductors of heat and electricity. They all are grouped together. They all have common characteristics. Group 17, the halogens. And we don't have to know the name of that. They all have 7 electrons in their outer shell, or their valence electrons. They really form compounds really readily with group 1. Chlorine's in group 17. It's going to bond with sodium. Sodium chloride is table salt. They bond really well. And then group 18 is your noble gases. All elements in group 18, they have a complete outer shell of electrons. They are all gases that are all colorless. They're all odorless. They're non-flammable. They're all very similar gases. So you get the idea that these groups that they're in, you can see they share common characteristics. They share common physical and or chemical characteristics with each other. All right. And so the grouping on the periodic table from the period, they all have the same energy levels. And once again, I'll show you. So the period, they all have the same energy levels. So if I go across, the energy levels, see this has 1 energy level on the inside and then another one on the outside. So this has 2. Well, beryllium has 2. Boron, 2 energy levels. I'm looking at the circles around the nucleus. 2, 2, 2, 2, 2. They all have 2. These all have 3, 3 circles around it. All right. So the period it's in will tell you how many energy levels, and it'll also tell you it'll increase by 1 atomic number. The group has very common characteristics. All right. They have very common characteristics. Now, valence electrons, we talked about this. This is going to be crucial. I'm bringing it up again because it is that important. Valence electrons are electrons in the outermost shell. Electrons in the outermost shell. Well, the way the electron configuration works, and it'll get more complicated when you get into, because there's like various s orbitals and p orbital. I'm not going to get into that right now. You'll do that in chemistry. But level 1, for our purposes, can hold 2 electrons. All right. So, and you can't go to the next level until you fill up that first level. All right. Can't go to the next level until you fill up that first level. Level 2 can hold up to 8 electrons. Level 3, now this one gets confusing. We're going to fill it. It can hold up to 18 electrons, because then that's where understanding like the orbitals, the s orbitals, the p orbitals, the d orbitals, that's where all that stuff will factor in, and it'll make more sense probably in chemistry. But for our purposes, it's going to fill with 8. It can hold up to 18, but it's going to fill with 8 electrons, and the rest will go to the 4th level. Because actually, I don't really know a good way to describe this without going too in depth. But the level 3 can hold up to 18, but if it doesn't have 18 electrons remaining, then it'll fill with 8 before it goes into the, well, I think it's the d orbital, whatever. And then the 4th will start to fill up, because actually there's parts of the 4th that have less energy than parts of the 3rd. So it's just, once again, it gets kind of, I don't really want to mess with it. So if you have electrons, you have 2 electrons in the first, that's what fills up the first, 8 fills the second, and then the 3rd can hold up to 18, but for most of our purposes, it's going to fill with 8, and then it'll go into the 4th. Now, the whole goal that we want to get to is this octet rule. All right. An atom, and this is going to be extremely important as well. Extremely important as well. Oh. All right, it's going to be extremely important because we are going to work on chemical bonding, and the whole point is to get 8 electrons. All right, because a full outer shell is complete with 8 electrons. The only exception to that is the very first elements on the periodic table. Level 1 is filled with 2. Every other energy level after that is filled with 8 electrons. All right. So the first energy level holds 2. This is the only exception to the rule. Every other energy level fills with 8. And so determining the number of valence electrons we talked about with bonding is going to be it's really easy. It's just, if you understand how things are grouped, like if you understand what the groups are and how this all works, like all elements in group 1, wait for it, have 1. I just talked about that. Group 2 has 2. Now, depending on the periodic table you look at, because some periodic tables, let me skip ahead to this one. Some periodic tables have it numbered like this, so it'll say like 1A, 2A, and then the transition elements are called like 3B, 4B, 5B, and then it picks up as 3A, 4A. Now, a lot of the periodic tables we use they just count the numbers. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So if it's numbered that way, it's really easy. Just we go, these all have 1, these all have 2. We skip this dip. We skip the dip. These all have 3, 4, 5, 6, 7, 8. The only exception to this rule on this one is helium. Helium, if you click on it, because remember we said these all have a full outer shell. Helium, that second level is filled with 2. That one is full. That first energy level is full with 2. So we can't fit any more into that. And so neon has 8 in its outer shell. Argon has 8 in its outer shell. Those are all full outer shells. Helium has a full outer shell also, but it only has 2. So that's really the only exception to that rule. That we talked about. All elements in group 3 or 13 have 3, 4, etc. Understanding how to find this out is going to save you a lot of trouble in our next unit, which is chemical bonds. All right, so it shouldn't be overly difficult. We'll talk about writing balanced drawing electrons. Drawing an electron dot diagram, it's really simple. Pretty much all you do, it says you write the chemical symbol. So if we wanted to draw an electron dot diagram for hydrogen, all you do is you draw the symbol and you put the number of dots around it that represent the valence electrons. So hydrogen's in group 1, it would have 1 dot around it. Carbon is in group 14, so it's going to have 4 dots around it. Phosphorus is in group 15. it's going to have 5 dots around it. Neon is in group 18. It will have 8 dots around it, signifying a full shell. Okay, so that's really all it is. We're going to get more work at that. I'm not going to spend too much time on that, but we'll work on that as well. All right, so that's the organization of the periodic table in a nutshell.